Salutations, mini mathematicians. Thank you so much for joining me. We're going to be working on 4.2D lesson today for Math AH, solve inequalities with variables on both sides of your inequality. So we've already solved inequalities, we've already solved equations with variables on both sides. So now we're going to mesh those topics together. So our purpose is to solve and graph inequalities, bring variables to one side to isolate. Of course, we want to bring our variable at the very end to the front so we can graph appropriately. You also have your PDF and this other handout, and we're going to fill in this handout together to get started. So, looking at graphing inequalities, when graphing, always include the boundary number. So the boundary number is the number that separates your solution set from your non-solution set. The integer to the right and the integer to the left of the boundary number. So taking a look, this symbol means, that's right, greater than. When graphing, we use an open circle and we shade to the right because that is where the values are greater than. So you can think about x being greater than a number. Awesome. So this next symbol means less than. Mrs. Barr likes to think that looks like a squishy L. So this is also an open circle because that boundary number is not included in the solution set. It does not make the statement true. And we shade to the left because all numbers less than that boundary number are solutions. They make the statement true. This next value is x is greater than or equal to. So greater than or equal to. Notice it's an or statement. You can't be greater than and equal to at the same time. This is a closed circle when we graph. The boundary number is included in the solution set. It does make the statement true. And it's greater than, so numbers that are greater than the boundary number are to the right. So we're shading to the right for our solution set. And this symbol means less than or equal to. So less than or equal to. It's also a closed dot or circle when you graph because the boundary number is included in your solution set, and we are shading to the left because it's all that boundary number and everything less than. Perfect. So when do you flip the symbol? So really important, remember, if you multiply or divide by a negative number, it makes the relationship the opposite. So your inequality symbol must flip. So if when solving you divide both sides by a negative value or number, you need to flip the symbol. For example, here, when solving, you can think that to get x by itself, I divide both sides by -3. I like to circle my symbol whenever I'm going to be flipping my symbol, and that means that x is less than -4. Good job there. Taking a look at the next one, if when solving you do what? You multiply both sides by a negative number or negative value, then you're going to have to flip your symbol. So here, to undo multiplying by -1/4, you multiply both sides by reciprocal, -4, -4 over 1. I'm going to circle my inequality symbol. So x is greater than -8. Perfect. And the last one, if when solving you blank the blank in the front, you need to move or switch the variable in front. So for example, here 5 is greater than or equal to x. Well, that means that x is less than or equal to 5 is how you want to look at that solution. Perfect. Make sure this gets attached in your notebook for points later. And we're going to be looking at 4.2D together. So 4.2t together. So looking at this example, it says a painting company charged $250 base rate plus $16 per hour. Another painting company charges a $210 base rate and $18 an hour. How long for the cost to be the same? So in your own words, what is this problem asking you to find? What is it asking you to find? It's asking when they cost the same. So at how many hours of work each company charges the same or an equivalent total. So let's take a look at B. It says define a variable, write an equation that models the situation, solve, answer in a complete sentence. So the variable here is going to be number of hours. It's the unknown. So number of hours, we're going to call it X. And we'll have the first company because we want to talk about what these unknowns are. And we're going to have the second company. So the charges for both of them. So the first company has a $250 base rate and $16 an hour. So we can think about as 16x plus 250, $16 for every hour. And the second company has a $210 base rate, but charges $18 an hour. So the equation to solve this would be 16x plus 250 is equal to 18x plus 210. I want to know when these two are equivalent to each other. Perfect. So taking a look, just like with any equation, our goal is to isolate the variable. So looking here, because we don't have our variable on both sides of our equation, I'm going to have the smaller king. Get rid of the smaller king bows down to the bigger king. So I'll have 250 is equal to 2x plus 210. Now to isolate my variable, I'm going to subtract 210 from both sides of my equation. From here, we end up with 40 is equal to 2x. I'm going to take half of both sides or divide both sides by 2 to get x equal to 20. Which tells me at 20 hours, both the companies charge the same amount. Asked me to answer in a complete sentence, so I will do that. At 20 hours, both companies charge the same amount. Excellent. So then it says, using your answer from part B, create parameters for which the first company is less expensive than the second one. So taking a look, if you look at the first company is going to be more expensive until you get to these 20 hours. And then it's going to become less expensive. So if we want to think about it, we could think about X being the number of hours. And we want to know when the first company is going to be less than the second company. Sorry, you couldn't see that. So we could substitute in our expressions from before. The first company, 16x plus 250, is less than the second company, which is 18x plus 210. From here, you could isolate your variable. Again, thinking about bringing your variables to the same side. So you'll notice we're going to be doing the same inverse operations as we did in part B. So the only difference is we have an inequality symbol now. So 250 is less than 2x plus 210. And if we kept solving, I'm going to subtract 210 from both sides. And we'd end up with 40 is less than 2x, making 20 less than x, meaning x is greater than 20. So here's a parameter. So the first company is less expensive when there is more than 20 hours of work done or completed, maybe done. And then it says, would the second company ever be less expensive than the first? Show your work and explain. So the second company ever be less expensive than the first? Yes, it's when the number of hours is less than 20. So more than 20, the first company is less expensive. Less than 20, the second company is less expensive. And we can think about that again. If we had first company is less than second company, this question is asking, when is the first company more expensive than the second company? So you could think about just flipping your inequality symbol for all of these steps above. So you end up with 20 is greater than x, so x is less than 20. So when is it less expensive? Yes, when the number of hours worked is less than 20. Awesome. So taking a look, we're going to solve a couple of inequalities. I'm going to do the odds with you, and then you're going to work on the evens and check your work with me at the end. So we are going to find the solution for each inequality showing all of our steps. We're going to graph our solution. We're going to write fractional answers in simplest form, scale the number lines appropriately, and we're always going to write variable in front or variable first. So let's take a look at this first one. Here, taking a look, the smaller king or lesser variable is negative x, so I'm going to add x to both sides. When I do that, I end up with 6x minus 9 is less than 3. To isolate my variable, I'm going to add 9 to both sides. When I do that, I get 6x is less than 12. I'm going to take 1/6 of both sides, or divide both sides by 6 to get x is less than 2. So this is our solution set. So I'm going to graph our boundary number at 2. And of course, for labeling my number line, I'm going to include 1 greater than my number and 1 less than my number. This is an open circle because 2 is not included in the boundary. And we are shading to the left because it's everything that is less than 2. Perfect. So like I said, we're going to be working on the odds together right now, and then you're going to work on the evens, and we'll go over those answers. So taking a look at 3, I need to distribute my factors first. So I end up with negative 4x plus 16 is less than 5x plus 15. Taking a look, my smaller variable is negative 4, so I'm going to add 4x to both sides. When I do that, I get 16 is less than 9x plus 15. I'm going to subtract 15 from both sides. When I do that, I end up with 1 is less than 9x. I'm going to divide both sides by 9, or take 1/9 of each side, and I have 1/9 is less than x. I need to have my variable in front and flip my symbol. That means x is greater than 1/9. So when we go to graph this, we're going to have 0 and 1 because 1/9 lies between 0 and 1. I'm going to have an open circle between 0 and 1, but a little bit closer to 0. And I'm going to shade to the right because it's all values that are greater than 1/9. And if you wanted to put 1/9 down here, you can to communicate clearly. Perfect. Let's take a look at number 5. Number 5 gives us this inequality. Taking a look, the first thing I'm going to do is distribute this -7. So I want to make sure I'm noticing it is negative. So 3x -7 times x is -7x. -7 times 5 is -35. Minus 5 is greater than or equal to 0. I'm going to combine like terms here. 3x take away 7x gets me -4x. -35 take away 5 gets me a -40. From here, all my variables are on the same side, which is nice. So now all I have to do is isolate my variable, add 40 to both sides. -4x is greater than or equal to 40. Take a -1/4 of both sides. Notice I have to flip my inequality symbol because I'm multiplying by a negative. I get x is less than or equal to -10. So this is my solution set. My boundary number is -10. 1 greater than -10 is -9. 1 less than is -11. Careful with those. I have a closed circle because -10 is included in my boundary. The boundary number is included in my solution set. It is make it true, and all numbers that are less than -10. Perfect. Good job there. And we're going to take a look at 7 on the next page. So here I am going to distribute these numbers. So 8 distributed gets me 16 plus 8x minus x is greater than 7x plus 7. Taking a look here, we end up with having to combine some like terms. So I have 16 plus 7x is greater than 7x plus 7. I'm going to bring all my variables to one side, subtract 7x from both sides. I end up with 16 is greater than 7. And I have to ask myself, oh my gosh, my variables cancel out. Am I left with a true or a false statement? This is a true statement. That means any value that I substitute in for x is going to make the statement true, which means your answer is all real numbers. So your answer is all real numbers. So what we can do to graph, we can show we include 0 in all numbers greater than or less than. We can also just not write anything on the number line and just have the graph going across. Perfect. Let's take a look at 9, and then you will do the evens, and we'll check in with each other. So it says determine whether each inequality is always, sometimes, or never true for any value of the variable. Explain your reasoning. So here, if I subtract w from both sides, I end up with 3 is less than or equal to -4, which we know this is a false statement. False statement, hence no solution and never true, because they ask us if it's always, sometimes, or never. So this is never true. If we got all real numbers, it's always true. And if we got a solution set, it's sometimes true. Sometimes meaning it's true when we are in the solution set, it's false when we are not in the solution set. Perfect. So we're going to go back to number 2, and you're going to work on 2 through 10. You're going to work on 2 through 10. So go ahead, pause the video, work on 2 through 10, and we're going to go over the answers in just a second. Perfect. Let's take a looky-loo. Number 2, you should have ended up with x is greater than 4. Open circle at 4, shaded to the right. Don't forget your arrow at the end of there. And you can always pause the video to check the look of my work. Number 4, your answer should end up being x is greater than or equal to -6. Don't forget to flip your inequality symbol. We have a closed circle at -6 shaded to the right. Don't forget to label -7, -6, and -5. Number 6 ends up being a rational number. We have a fraction here. So I cleared my fraction by multiplying by 3 on both sides to get you started. We end up with x is less than or equal to, you have 34 thirds or 11 and 1/3. So between 11 and 12, we have a closed circle, a little close to 11 and shading to the left. That's everything that's less than. Number 8, what is the mistake? Well, the mistake is they did not use the additive inverse of -1. They needed to add 1 to both sides, not subtract 1. So solved correctly, showing your work, you should have gotten x is greater than 3 and 1/3 or x is greater than 10 thirds. And when you did the last number, number 10, you end up with t is greater than 0, which means this is sometimes true. Only when t is greater than 0 is this true. If t is equal to 0 or less than 0, it is false. So that's why this is sometimes true. Great work, mini mathematicians. You have reflection number 1 to finish for this lesson. Thank you. Do your best. Be nice to everyone. And time's up. Thank you so much.